Hello everyone. In this video, we're going to be integrating a radical function. We have dx divided by 1 plus the square root of x minus 2, and we're going to be integrating this function. So how do you integrate something that is radical, right? Well, it's in the denominator to make matters worse, because if it was the numerator, you could easily solve it, couldn't you? So let's go ahead and see how we can solve this with different approaches. Even though they're not very different, there's definitely some variations on this. So let's go ahead and start by setting the square root of x minus 2 equal to u, okay? By setting square root of x minus 2 equal to u, we're going to be using a u sub here, by the way, in case you didn't know. We're going to square both sides. That's going to give us x minus 2 equals u squared. And now we're going to be differentiating both sides, in other words, finding the dx and du. That's going to give us the derivative of x is 1, so it's just going to be 1 dx, or just dx, equals, how do you differentiate u squared? It's 2u du, right? And if it's your birthday, happy birthday to you. Okay, great. So now we have dx equals 2u du. We can go ahead and substitute that into our equation. That gives us 2u. And then let's go ahead and divide, and then we'll put the du at the end. And then in the denominator, we have 1 plus u. How simple is that, right? Great. So that's what we need to integrate. Now our integral is in terms of u completely. Make sure you do that, because sometimes I do see that people use u subs, but they don't replace everything, and they still have a mixture of u's and x's. That's not good, okay? Great. Now let's go ahead and proceed with the integral. Now, this is another type of question. How do you integrate when you have a denominator, right? You could use partial fractions, but that's not even necessary, because in this case, it's actually fairly simple. Notice that the degree of the numerator and the denominator are the same. So we could use a little trick here. How? First of all, let me write this as 2u divided by u plus 1. And notice that if I double u plus 1, I get 2u plus 2. So here's what I can do. I can actually add 2 and subtract 2. They'll cancel out, right? Then why are we adding? Because we want to make this separable. So now we can go ahead and actually separate these into two things, 2u plus 2 over u plus 1, and you'll see why that works. Minus 2 divided by u plus 1. Now, if you do factoring here, remember we told you u plus 1, if you double that, you get 2u plus 2, so you already know it's going to be 2 times u plus 1, and in the denominator, you have u plus 1, and then you can definitely go ahead and simplify this, right? U plus 1 is going to cancel out, and you're going to end up with something super duper simple. So this is basically how you can split it up into manageable pieces. Now what we're going to do is we're going to integrate each one of these. Let's go ahead and do that with du. So it's going to be 2 du, and then we're going to have 2 over u plus 1 du. Obviously, the first one is fairly simpler. How do you integrate 2? 2 is a constant, so you got to think. And our variable is u in this case. Be careful. The derivative of which function with respect to u is 2? And the answer is 2u. Again, okay? It came up, sorry. So what about the second part? Well, if you know that 1 over u is the derivative of ln u, right? And of course, I'm not talking about u being a function of x in this case, because we're integrating with respect to u. Does that make sense? It's a little different. So this type of thing will be an ln, so I can write it as 2 times ln absolute value of u plus 1. And of course, we have to put our infamous constant at the very end. Remember, some professors are so strict that they'll take away points, sometimes even give you a 0 if you do not add the integration constant, okay? Very, very important. Now, this is our result, but we kind of have to go back and substitute what we have. What is u? You kind of need to go back and find out, if you didn't take notes. U is the square root of x minus 2. So let's go ahead and put a little note here. Okay. Then we'll replace u with the square root of x minus 2 minus 2 times ln square root of x minus 2 plus 1 plus the constant. Okay. Since square root of x minus 2 cannot be negative, square root of x minus 2 plus 1 cannot even be 0. It has to be greater than 0 all the time. We don't really need the absolute value, so we can go ahead and remove it. You don't have to, but it just looks a little better. And we can now write it as follows. And this is basically what the result is, right? Okay, let's go ahead and take a look at the second method, which is actually a slight variation of the first method. Now, are there any other methods for solving this problem? You're gonna let me know in the comment section, right? All right, great. Let's see how we can handle this slightly bit differently. So, now remember last time we set square root of x minus 2 equal to u. So why not pick or choose the whole thing? Why don't we set it equal to u this time? Of course, these u's are not the same, by the way. And if you don't want to use u, you can just use t, okay? All right, let's go ahead and use t this time. So by doing that, we're basically assuming that 1 plus the square root of x minus 2 is equal to t. Now remember, to find dx, I kind of need x, right? Otherwise, I'm going to have to deal with some radicals. Let's go ahead and isolate x first. So subtract 1, and then square both sides, of course. That would be natural, right? And now from here, you get x minus 2 equals t minus 1 quantity squared. It's up to you if you want to expand it. And then you should be adding 2 to both sides because, again, we want to isolate x. Even though it's not strictly necessary, I would recommend that you do it. Okay, great. Now, based upon our choice of t, which could be u as well, we got this. So now how do you find dx? Easy. You're just going to differentiate x, which is 1 dx. And then on the right-hand side, we get 2t minus 2. If you're a tutor, it's like you're a tutor, and the person you tutor is your 2t. And then this is going to be multiplied by dt. Okay? Makes sense? Now let's go ahead and substitute these. What is our expression? Dx over 1 plus the square root of x minus 2. Let's go ahead and replace dx with 2t minus 2 dt. And then the denominator is just going to be a big giant t, right? And that's the good thing about it. I think the second method is slightly better because it doesn't cause us to do an extra step for separation. And then from here we get 2 minus 2 over t. Of course, we're going to integrate this easily. You see, it's automatically separable. This is going to be 2t minus 2 ln absolute value of t plus our constant again. But this time we had a different t, right? T was 1 plus the square root of x minus 2. 2 times 1 plus the square root of x minus 2 minus 2 times ln. As before, we don't need absolute value. So we're going to go ahead and write it like this. And guess what? Those two results are exactly the same. And why would they be different, right? We're using different methods for the same problem, but we're getting this result. Okay, great. Now, how can we approach this problem differently? Is there a third way to do it? So that's what I want you to talk about in the comment section down below. Let us know if you know of any other methods that could be used to solve this integral. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe. Take care. Don't forget to check out aplusbi, the short channel on SyberMath. And bye-bye.